Welcome to Physics for Real, and we're going to have a quick look at refractive index in a little bit more detail here. So we've already talked about refractive index in another video, and we said that the refractive index is equal to the speed of light in a vacuum divided by the speed of light in a particular material. So what does that mean and what does that look like? Let's have a look at a couple of examples. So if we move on to this example here, we've got some values here. So basically the speed of light in air is 2.99 times 10 to the 8 meters per second, which basically rounds up to 3 times 10 to the 8 meters per second. So the speed of light in air and in a vacuum are roughly the same. The speed of light in glass is significantly slower, and you've got the speed of light in oil and in water. And we're going to work out the refractive index for each of these. So if we go back to our definition of refractive index is equal to the speed of light in a vacuum divided by the speed in a particular material. So it's the ratio of the speeds of light in a vacuum to the speed of light in a particular material. So let's work that out. Whoops. Let's get rid of all that and that. Whoops. I'm not quite working well with this pen here. So the speed of light, let's work out the refractive index for air. So if you were to do air, which is 3, so the speed of light in a vacuum is 3 times 10 to the 8. You would then divide that by the speed of light in air, which is 2.99 times 10 to the 8. And if you type that into your calculator, you're going to get 3 divided by 2.99, which basically gives you 1.0033. So essentially the refractive index for air is 1.0 because the speed in air and the speed in the vacuum are almost identical. Okay, right. So that's refractive index for air. If we were to look now at the refractive index for glass, again you'd work out N equals the speed of light in a vacuum divided by the speed of light in glass, which is 2 times 10 to the 8, and that's going to give you a value of 1.5. So there's that one. Okay. So what we're saying there is basically the speed of light in glass is about 2/3 of the speed of light in air or a vacuum. Okay, so if we rub that out again, and let's do the next one. So the next one's going to be the speed of light in a vacuum. So let's do that to the right number of decimal places this time, divided by the speed of light in oil. Okay, so if you type that into your calculator, you're going to get 3 divided by 2.34 essentially, which is going to give you 1.28. So that's the speed, that's the ratio of the speeds in a vacuum to the speed in oil. All right, and then the last one, if we were to look at the speed of light in a vacuum compared to the speed of light in water. Okay, you get 3 divided by 2.26, which is going to give you 1.33. Okay, so that's what we mean by refractive index. It's just the ratio of these speeds. Okay, and most of the time you're going to be dealing with glass, so the refractive index for glass is going to be somewhere around 1.5. It could be 1.56, could be 1.48. It depends on the type of glass. And then also you may deal with water quite regularly as well at A level. And you may well also deal with plastic. Now the speed of light in glass and plastic is very similar. So the refractive index for plastic is usually around 1.48 or something like that. So let's have a little look at what we can do with this. So remember, the refractive index is the speed of light in a vacuum divided by the speed of light in a particular material. So let's say we have some material that's got a refractive index of 1.45. Okay, so that's the refractive index of this material. What we can do then is we can work out the speed of light in that material. Okay, so we're just going to do C divided by N. So that's the speed of light in air or a vacuum divided by 1.45. And that's going to give us our speed in that particular material. So that's going to give us, if we put that into our calculator, we're going to get, 1.45. So it's going to give us 2.07. So 2.07 times 10 to the 8 meters per second. So we now know that the speed of light in this material, whatever it is that there. It's going to be 2.07 times 10 to the 8. So that's one of the ways in which we can use the refractive index.